Hello everyone, my name is Tea Rukavina. I'm a research development engineer at ORANO, and I'm a doctor in numerical mechanics. Today I will present you the topic AI at the service of engineering that I have prepared with my colleagues Corentin Macron and Joanne William from the data science team in ORANO Projet. So as you probably know, ORANO is a world leader in the recycling of nuclear fuel and in the whole process regarding uranium mining, extraction, and also enrichment, but also in recycling the fuel and dismantling nuclear power plants. Engineering is a very important part of a nuclear projects because we can ensure the safety and efficiency of our nuclear facilities. So ORANO has understood very quickly that without investing in new technology, we cannot make a huge progress. So one of these technologies is artificial intelligence. So with AI, we can actually improve our performance in engineering tests by reducing computational time, by optimizing cost and efficiency of our industrial equipment, but also with helping in decision making. So usually in the nuclear industry, as I'm sure you know, there are really strict regulations and constraints that we have to respect to ensure all this safety. And sometimes we are relying on engineering experience to help us make decisions. And this is good, but it can lead to errors. So we want to improve this, and we want to add this artificial intelligence part to help us make optimal choices that can lead also to cost reduction. So we are always talking about AI, it's everywhere, one would think it's a sort of magic, but of course it's not magic, it's really concrete, it's something based on mathematical and statistical methods. And you also have to know programming to implement it well. And I always like to remind everyone what is AI. Basically, this is a set of techniques that helps machine and computers mimic human behavior. So there is a subset of artificial intelligence that is called machine learning. And here we really rely on some historical data to make predictions about some events based on big databases that we are using. There is also deep learning that includes, of course, neural networks. So this notion of having a lot of data is really important here because AI actually uses this data to find patterns and to create some rules. So we don't have to program explicit rules that the program can follow, but the AI is building its own rules, actually. So AI learns from examples and not from principles. And just to remind you, this data, it is all around us, and it can come from experimental data. It can come also from some sensors that we can have on our equipment. But what we are doing a lot also in engineering is having synthetic data that we are generating by our own computation. So it can help us be more efficient in this area. So a brief summary of the presentations, because this is a workshop, so I suppose that you have come here to see what we are doing and not some general things. So I will show you some applications that we have done or that are in development in ORANO projects, and the most of them are related to physical models. I will explain what it is, the surrogate models, and I have two big examples that I will show you of something that has been really done. It's one a long life battery example and one example of optimizing civil engineering structures. Then we have played with AI also for creative design in generating automatically piping networks, and also a little bit, let's say, sometimes less technical in this sense, but really important for management and also for our for operators at the site is AI and decision making for choosing some equipment, but also for predicting some risks in projects. So let's go. So the first thing that we are doing is AI and physical models, and in ORANO projects we are doing a lot of numerical modeling. So this means that we are trying to simulate the behavior of structures by some method to discretize the domain, let's say like finite element or finite volume method, as you can see here. And these methods are very, very accurate, but they are expensive, and they are expensive in terms of time and in terms of computer resources. So we want to find something here that can help us reduce this expense. That's why we are using surrogate models. And surrogate models actually, they are trained from the inputs and outputs of previous calculations done by classical models. So you can see on the schema here, you actually have the inputs, and then you have the standard simulation that takes into account building the geometry of a structure, you have the mesh generation, and then you have the finite element analysis, for example, that gives you the results in terms of stress or displacement or something else. And now what we are trying to do here is to replace this, middle part with a surrogate model, so with an artificial intelligence that has been built on thousands of these sort of calculations to give us the output instantaneously. And here it's also important to say that AI is not perfect, and of course it makes errors, but it is for engineers actually to estimate these errors and to know what we are talking about when we are using it. If it is something in the range of 20–30%, of course we will say it's not a good AI. But if we have something, let's say, smaller of 2–3%, it is something that we can really use to solve our problems. Another thing that is good about the AI, since it's very, very fast, is the design optimization. Because usually in standard numerical models, we always stick to the same design, or we just try to do some variations because we don't have the time. There's always a constraint of not enough time, not enough money. But with AI, we can actually try many different configurations and find the optimal one, so we can just validate this optimal variant with a standard calculation. And that's why we have built on top of this knowledge to develop, let's say, our first example that I will present today. And just to give you some context, so it is RTG, radio isotopic thermal generator. When you have to do deep geological storage of nuclear waste, you need some sensors to see if everything is going all right where you have put the waste. And usually you don't want to have connections with the world, let's say, on the surface, because it is on a depth of 500 meters. So you would like to have some battery that would last long and that would not need a new power source changed all the time. So we have developed in collaboration with our partners this long-life battery based on americium-241 that is actually a byproduct of the recycling in our La Hague nuclear facility that can help us actually reuse this element. That is also a good thing for sustainability. So as you can see here, there is a design of this long-life battery, of this thermal generator. But to find really the optimal design, our engineers have to find and do many calculations to obtain something that we can say it's optimal. And since it's a complex, nonlinear relationship and it's a problem that is high-dimensional and multi-physics, this is not an easy task to do. So just here is a small schema of what we have done here with AI to help our engineers actually to make this optimization. You have this database of COMSOL calculations with inputs and outputs that are related to the RTG. Then you divide it usually in training data and validation data, as you always do in machine learning. You train the model, you validate the model, and this validation and this quickness of response can also help us explain, like with explainability, to explain what's going on, for example, which variables are the most important, and so on. And then we get to the surrogate model. Actually, this is just the implementation of this AI that we have tested into some, let's say, some program that we want to do. Then we can pass to the optimizing part, and we want to actually minimize this mass of americium that is used in the battery, because it's a very expensive material, so we want to have some reduction in its mass that is used. Of course, we have to respect some constraints, in this case, electrical, thermal, and geometrical constraints. And once we are using our optimizer to find the optimal design, we validate it once more with a standard 3D COMSOL calculation, and we can say, okay, we have obtained something that is really good. The AI was trained and validated with only 110 COMSOL calculations, and the neural network has been the most performant one. We have tested many different models, as you can see here, for example, starting from linear regression to random forest and gradient boosting. And even though this database is small, it is well constructed, so it was sufficient to reach 1% accuracy. This is also an example to say that you don't always have to have a big, huge database to expect good results, but in our case, it worked only for 110 calculations. And to conclude on this example, with the classical approach with this COMSOL model, actually it's some sort of blind search, let's say, because the multiphysics is very complex, and the Americium mass was reduced by 1% in 6 months of calculations, because these calculations are very long. And with the use of AI, we have been able to do results-aware smart search, and in only 3 days we have reduced this Americium mass by 3%. And this is something that, when you take into account the cost of the element, it's really something that can gain us 300,000 euros for 10 RTGs. So it's not bad. The next example I will tell you about, it's regarding civil engineering. So probably you know that in nuclear projects, when you build a new facility, the civil engineering part is a very consequent part of the budget. It's 30 to 40%. So actually choosing the right dimensions of structural elements is a really important part, because the small change in thickness, for example, from 40 to 30 centimeters of a reinforced concrete slab that you can see here, can give some really good reductions of cost of the total project. So our objective here, as you can see here, you have a slab that has some steel reinforcement inside, because it's concrete and steel working together to support all the loading here. To predict the displacements and the quantity of this steel reinforcement that we are putting in, and also to optimize this slab thickness to reduce the total cost. We have done here a training of AI on 5,000 finite element calculations that were performed in the software Sophistic. The input data included materials, geometry, boundary conditions, loading, and here it's also important to say that we have taken into account seismic loading. That can be really important for our facilities, and it's always the thing that puts a lot of loading on our slabs. And the output data is displacement and steel reinforcement quantity. We have here tested different models, as in the previous example, and neural networks provided the best fit. And you can see here on the small graphics, actually, that you have the relationship between predicted and expected values. And since they are very, very close on this central line, that means that we have a good agreement and good fit of results. And we have obtained a mean relative error of 3% for displacement and 7% for steel reinforcement. That is in line with the objective we have put to ourselves to be in less than 10%. And we have also significantly reduced the computational time by a factor of 1,000. So this also can help our engineers go very, very quickly. Also, this was our, let's say, first big AI that was deployed industrially, and today it has been implemented in the AVEVA 3D software, and our engineers are using it actually every day in their work. So it is something that has a nice graphical interface, and with just one click you can get all the data directly from the model. So you just have to put a few information, and with one click you get the results, and you get the optimal thickness of the plate. So it's really, really interesting. Of course, like in the RTG example, this is not something that you can say to the nuclear authorities, okay, we have chosen this dimension because the AI has said so. This is just something that can help engineers find the best solution, and then of course they do a standard 3D calculation of the whole building, because we have to ensure all the safety standards by, let's say, this classical means. And in terms of gains, you have the reduction of the number of engineering labor hours. You have the reduction of the quantity of materials used, so less steel, less concrete. And what is even more important, less changes in the project documentation and avoiding errors. And this is a part that can gain us really millions of euros, because sometimes in the projects it happens then one team, or let's say one part, changes something because the loading has changed, and they didn't notify the other one. So actually, it creates some sort of little bit of a chaos. And with the artificial intelligence giving us a hand here, we can avoid this kind of situations and save also a lot of money. So the total gain for this project is 10 to 15% in the design phase and also during construction. Now something a little bit different, just to show you that what we can do. We are also doing some sort of analysis of transient systems. So this means that when you have problems that are not statical but dynamical, that they have dependence in time, artificial intelligence methods you can use are a little bit differently implemented. So you basically do time series analysis. So just to see this example, this is a liquid extraction column, and it has been measured with some sensors. This blue curve that you can see here are the real experimental data. And with our machine learning approach, we have managed to obtain the orange curve, so to simulate the behavior of such a system. Also, a similar problem in the transient domain, but even for more complex systems that, let's say, maybe we don't understand fully what is happening, like in the sense that we cannot model it with one or two equations, but it is something very complex, let's say a multi-physics system. We can also train AI with experimental data that are issued from real equipment. So, for example, when you see in this recycling process, we have the vitrification process, when you take nuclear waste and you vitrify it to put it in this sort of containers that diminish radioactivity. So this kind of process is, there is non-Newtonian rheology, there are complex thermodynamics, thermohydraulics, phase change, calefaction, electromagnetic heating. So you can imagine that we cannot describe it very, very easily. But AI actually is powerful enough to find some patterns and maybe to help us gain insight into this sort of problems. So this, in this example here, AI can help us learn from industrial data. It can help us also prevent equipment failure and optimize the process. So all the good things that we would not be able to do just by ourselves. Another part, and this is just a small slide to illustrate what we can do regarding creative design. This means using AI to draw, for example, piping networks, as you can see here. And I imagine in all your facilities, wherever you come from, there are a lot of pipes, cables, and so on. This is something that engineers do by hand. And if they have a lot of experience, sometimes it goes quickly, but never as quick as the computer can do it. So we are training our AI with our partner Data Advance to optimize this drawing of piping in 3D buildings. So these are complex networks, and you have to respect some constraints that are put on here, because of course you have slabs, you have walls, you have holes in the walls that the pipe has to go through. So it is something that you have to take into account to draw it. And it has been very performant in 2D and 3D. So we are going to industrialize this example in the next months. And now the last part of my talk is AI in decision making. And this is something, let's say, a little bit less related to modeling, but more related to something like helping people, helping our colleagues to make good decisions based on data. For example, there is a problem of choosing the best instrumentation technology for measuring certain things like temperature, pH, humidity, or something like this. And the engineer, regarding all these parameters listed here, like flight temperature, corrosivity, but also maintenance possibilities, he has to choose the right equipment for the right problem. And these are sometimes long, long lists of sensors, instruments with specifications, and he has to go through it to find the best one, and sometimes he finds something that is not optimal. So with the AI, we have managed to train it to choose between 100 different types of instruments with 95% confidence. So it is something that can really save us some time and ensure that we are having always the right technology at the right moment and the right position. Something AI can also help us with, these are detecting project risks, and it is more related to project management. So usually when you have a project in a big industry like ours, there are always some delays, budget overruns, technical difficulties, and sometimes you are not aware of them in time. So what you want to do is actually predict when this sort of crisis is going to happen and to notify the people that have to make decision quickly to avoid it or to help mitigate it. So we have partnered with Expert AI to use their tool that is called Cogito. It's a NLP, like a natural language processing tool, that takes all the documents. In this case, we took all the mails that were exchanged on a project during its duration. Of course, we have anonymized the mails with report to GDPR. And so what we wanted to do is actually find this correlation between the negative emotions that were present in the mails and the risks associated with the project. And all this related also to special entities, like is it a problem with the partners, is it the problem with an equipment, is it the problem with management, and so on. So for example, in the little graph here, you can see we want to find these extraordinary events that have problems, like people that are discussing some technical concerns in mails, and they are keeping it to themselves. They are not notifying the management, and the AI can help us detect this kind of let's say, situations that are red alert situations, and notify people that can react. Oops. So we have made a proof of concept to detect these signals before a crisis. Another project that is with the same partner and that is a little bit related to this because it also uses NLP, it's finding inconsistencies in the documentation. So now it seems a little bit abstract if I say it, but usually it's, you have a lot of technical notes, you have a lot of reports regarding different areas of our project. And sometimes you have a value of, I don't know, 400, but in one document it's in tons, in the other one they made a mistake and they put it in kilograms. So this is inconsistency that you want to find, and you want to change it before it causes some trouble. Also, we want to detect the changes of technical specifications. Like, for example, at one moment at the project, the reference temperature was changed from 18 to 20 degrees, and not all the teams were notified. So with this NLP tool, actually, that analyzes all this documentation, we can notify all the people at let's say, at the same time, and to prevent them from using wrong values in some calculations, and that can also save us a lot of money. The idea is to make a dashboard with main project parameters, so everyone can at all times of the project be aware of what's happening, what has changed, and if there are any inconsistencies. And this is my last slide to conclude, because I don't want to go further into details. We will have a discussion after that if you want to. I hope this has helped you to see how we develop and deploy AI-based solutions. Maybe it has given you some ideas. Maybe you already do AI in your company. So I would like to hear about that, so we can discuss about it further. So this can all help us to increase engineering performance, reducing computational time, avoiding errors, and also allowing our engineers to perform tasks with more added value for the company. And all these tedious tasks that are, let's say, repetitive, that take a lot of time but don't give many added value, we want to eliminate them and replace them with artificial intelligence. So just a non-exhaustive list of current projects and ideas for future work. That would be automatic definition of safety requirements. That is a very important thing in nuclear industry. Then quality control with image processing, for example, for welding. Then data visualization and dashboards for industrial data. And this is not only for our engineering teams, but also from other business units in ORANO, because we are a big group. So it is really to help people in the facilities to see all the time what is happening with their equipment and to help them make good decisions. And also these kinds of insight can lead to predictive maintenance of equipment. So thank you very much, and I hope you will have some questions that we can discuss further. Thank you.